Alright, so this is page 4, starting with number 31. It says write a third degree polynomial in standard form with these zeros. And so if it has these zeros, it's going to have these factors. If negative 3 is a 0, x plus 3 will be a factor. If 4 is a 0, x minus 4 will be a factor. And if negative 1 is a 0, x plus 1 will be a factor. So it wants it in standard form, though. This is factored form, so I could leave it like this. That's factored form, but it doesn't want it in that form. It wants it in standard form, so what I'm going to have to do is multiply those out. I'm going to start by multiplying these two together by using FOIL. I'm going to take x times x is x squared, x times negative 4 is negative 4x, 3 times x is 3x, 3 times negative 4 is negative 12. That simplifies to x squared minus x minus 12. So then I'm going to take that and multiply it times x plus 1. So I'm going to take x squared times x is x to the third. X squared times 1 is x squared. Then I'm going to take negative x and multiply it out. Negative x times x is negative x squared. Negative x times 1 is negative x. Then I'm going to multiply the negative 12 out. Negative 12 times x is negative 12x, and negative 12 times 1 is negative 12. So my final answer is going to be x to the third. I've got an x squared minus x squared. Those are going to cancel each other out. Negative 1x and negative 12x is negative 13x minus 12. And that is a third degree polynomial in standard form that has those zeros. Number 32, we're going to sketch this graph. So here's one thing that I know we could do. I can factor out an x right away. So I'm going to factor out an x. This is going to be then x squared plus 2x minus 15. Well, then I can factor my factor again. I'm going to have an x here and here that multiply together to give me x squared. And something here and here that multiplies to negative 15 that adds to 2 is going to be a positive 5 and a negative 3. So that means I'm going to have a 0 at 0, at negative 5, and at 3. So here's negative 5, here's the one at 0, and here's the one at 3. They all have a multiplicity of 1, which means they're just going to go through it at all three of those points. My leading term is positive, which means after it goes through this one, it's just going to go up. It's going to go through this one, it's going to go through this one, and end up going down. Now the nice thing is you guys are going to have your graphing calculators on this test. So you can just graph that equation and transfer the graph on your calculator to the graph on your paper or in Canvas. Take a look at number 33. State the zeros and their multiplicity. Well, there's 3 zeros here. There's one here, there's one here, and there's one here. It looks like there's going to be a 0 at negative 3. It has a multiplicity of 1 because it goes through there. Another 0 is going to be at 1. It's going to have a multiplicity of at least 2 because it bounces there. And then another 0 is 5, and it has a multiplicity of probably 1 because it goes through there. Now this could be 4 or 6. This could be 3 or 5, and so could this one. The fact is, this one's odd, and so is this one, and this one's got to be even. Then it says, state the minimum possible degree. Well, if this has a multiplicity of 1, and this has a multiplicity of 2, and this has a multiplicity of 1, that means the degree has to be a minimum of 4. Another way to look at it is it changes directions 4 times. It goes up, down, down. There's 4 changes, so the degree has to be 4 at a minimum. And then to state the number of real zeros, it has 3 zeros. And those 3 zeros are negative 3, 1, and 5. Let's take a look at 34. 34, it says, circle the picture of the graph that represents a quartic equation, a quartic function with 4 real zeros. Well, this one only has 1, 2, 3. It's not that one. This one has 1, 2, 3. It's not that one. This has 1, 2, 3, 4. And this one has 1, 2, 3, 4. So it's one of the last two. There's a problem with this one, though. If it's a 4th degree polynomial, that means it ends with both of the n values going either up together or down together. But this one goes down and this one goes up. It's not that one. It's got to be this one because they both end up going up. So it's got to be this graph. Let's take a look at 35. 35, it says, state the value of Q1, Q2, which is the median, the Q3, the range, and the IQR, the interquartile range of this box plot. Well, it looks like Q1 is, that would be 65, 66, 67. So Q1 is 67. Q3 3, which is the end of the box over here, that's 71, 72, looks like that's 73. The median value, that's the inside of the box, that's 68, 69, 70. So the median value is, what did I say that was? 68, 69, 70. The range goes from the highest value, which is 76, minus your lowest value, which is 54. And if I take 76 minus 54, that's 22. So this is my range. The inner quartile range is my Q3, which is 73, minus my Q1, which is 67. If I subtract those, that's 6. This is my inner quartile range. That's number 35. Let's move on. 36. Use the discriminant to determine the number and type of real or imaginary for the given quadratic equation. Well, the discriminant, we know the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. The discriminant is just this part inside, the b squared minus 4ac. If that's positive, there's two real answers. If it's negative, it has to be imaginary because we would be taking the square root of a negative number. And if it's 0, there's only one answer, and that would be negative b over 2a. So let's figure out what it is first. B squared, well, that's negative 5 squared is 25, minus 4 times a, well, a is 3, times c, which is 6. Well, that's 25 minus 4 times 3 is 12. 12 times 6, I think, is 72. But the point is, this is going to be a negative number. Well, that means I'm going to have two imaginary answers for 36. Number 37. A ball is thrown up in the air, and the function, which is this, gives the height. Models the height of the ball h in meters after t seconds. How long does it take for the ball to hit the ground? Well, that means it's going to be negative 4.9 t squared plus 30 times some time plus 3. That we want to know what t value would give us a height of 0. We're going to solve that equation. Probably, there's several ways we can solve that equation. We could use the quadratic formula for sure, but another way that we could do this is to graph it. And so let me just show you how, or one way that you could do this problem by graphing it. I'm going to clear this. This is going to be negative 4.9x squared. We've done problems like this, but we used a lot of negative 16s, which is feet per second, and this is meters per second. So same kind of question, just different number to start with. And then plus 30x, and then plus 3. And so I don't know what my window is, the normal window. So I'm going to graph this, see what happens. Looks like it goes up, and then it comes back down. Well, what I want to know is when does it hit the ground? I could change this to get a better idea. If I want to show the top of this, maybe I'm going to have it go up to 100. You can see it comes up, and then it goes back down. Well, here's where it hits the ground, that point. That's a 0. So I've got to find that 0. I'm going to go second, trace. I want to find that 0. So I'm going to move my cursor, it says left bound. I'm going to move my cursor close to it, but to the left of it, then to the right of it, and just press enter. And y is 0 and x is 6.22. 6.22. And it says rounded to the nearest tenth, so that would be 6.2 seconds. It's going to hit the ground. I could have also done that with the quadratic formula. Completing the square, all of those would work, but so would graphing. Take a look at 38. Solve and graph this compound inequality. So what I'm going to do is first solve this part of it. I'm going to get this x by itself by adding 2. I would have negative 2x is greater than negative 8 plus 2 is negative 6. Then I'm going to divide by negative 2. So negative 6 divided by negative 2 is 3. But when I divide by a negative number, the sign changes. I'm going to do the same thing with the other side. I'm going to start by subtracting 7. So 2x is greater than or equal to 18 minus 7, which is 11. Divide by 2, and x is going to be greater than or equal to 11 halves, which is 5.5. So here's 3. Here's 5.5. Here's 3. So there's an open circle at 3, and it's less than that, which is in this direction. There's a closed circle at 5.5 because it's equal to it, and it's greater than that. So it looks something like this. And then the last one. write this polynomial in standard form. So here's what I'm going to do. I'm going to multiply these together first. I'm going to take 2x times x is 2x squared. 2x times negative 4 is negative 8x. 5 times x is 5x. 5 times negative 4 is negative 20. Then I'm going to simplify that. This is 2x squared. Negative 8x plus 5x is negative 3x minus 20. So there's the first part of this. Then I'm going to subtract the second part, which means I'm going to take x plus 2 squared. That means x plus 2 times x plus 2. I'm going to FOIL that. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. 2 times 2 is 4. Well, that is x squared. 2x and 2x is 4x plus 4. So I'm going to take this minus this. So if I'm going to subtract this, that means I could take this negative 1 and distribute it and make all of these signs negative. Negative x squared, negative 4x, and negative 4. And now I can combine like terms. 2x squared minus x squared is just x squared. Negative 3x and a negative 4x is a negative 7x. And negative 20 and a negative 4 is a negative 24. So it would be y equals that. And that's what it would look like in standard form. That is page 3.